Hello viewer, welcome to my channel. In this video, we are going to learn derived units. Here, derived quantity. Derived quantity are those quantities that depend on the fundamental quantities. The quantity that depend on the fundamental quantity is said to be derived quantity. It has two or more fundamental units. We'll take this example. What is the derived unit of the following quantity? Velocity, acceleration, force, work, and energy density. These are derived quantities. Then we are to find a derived unit. To do this, very simple. Our velocity is displacement over time. Now, displacement is measured in meter because the unit of length is meter. So displacement is measured in meter. That is the standard unit. Time is measured in second. That is the SI unit. Now, this is meter per second, but we can write this linearly as M times 1 over S. So this is M times S will come up. The power of S is 1. 1 over is minus 1. This is now ms minus 1. This is a derived unit of velocity, meter per second. Meter per second. Now we take B, acceleration. Acceleration is velocity over time. And velocity is displacement over time, all over time. Now, displacement is meter, it's measured in meter, time, second, over S. So each time, the one down is dividing the whole of the fraction of M over S is divided by S. So we simply say S times S. This denominator here times denominator here. But if it's not dividing the whole, we don't do it like that. So from here, we'll now have M over S times S, which is M over S squared. Linearly, we have M, the S will come up, S, because it's down over minus the power 2. So this is meter per second square. Very simple. We take the next example. Force is mass times acceleration. This is force. Now, mass is measured in kilogram times acceleration is velocity over time. Now, velocity is displacement. Over time, all over time. Kilogram, displacement is meter, time, seconds, time, seconds. Kilogram times S times S, S times S. Remember what I said. That's why I quickly say S times S. So this is kilogram times meter. S times S is S squared. So this is kilogram times meter. S will come up. S raised by minus 2. So we remove this multiplication sign. We have K, G, M, S minus 2. So this is the derived unit of force. We take D, work, force times distance. Now, what is force? Mass times acceleration times distance. Now, mass is kg times acceleration is displacement over time, just the way we did it there. So we now, I will just write meter per second square. We know how to find this. We find this. It's not hard because I don't want to repeat it. Times distance m over kg. M times m becomes m square. Then s raised to the power minus 2. We remove the multiplication sign. It's km square s minus 2 raised to the power 2. So this is the dimension. Sorry, this is the derived unit of work. Kilogram meter square per second square. Then we take the last question, energy density. Energy density has to do with work. So energy density is simply energy times density. So let's start it this way. Now energy and work have the same measurement. So energy is force times distance. Force times distance. Times density is mass over volume. Now we find the derived unit of force. Force is mass times acceleration times distance times mass over volume is length times breadth, length times breadth times height. Now mass is kg. Acceleration, we have found it before, is meter per second square times m times mass kg over L is m, breadth m, height m. So this will now be kg m s minus 2 raised to the minus s raised to the minus 2 times kg m over m times m times m. This m will cancel this m. We are left with this times this kg square ms minus 2 over m times m. This m will cancel this m. We could cancel here, but I didn't want to do it that way. It's still the same. You cancel here, fine. This is kg square s minus 2 over m. So we make it linearly. K, we write it linearly. We have km. The power is 1 coming up because it's down, minus the power 1 s minus 2. So this is the dimension k square. So this is the dimension of energy density. Kilogram square per meter per second square. Very simple.